Hi, I'm Alberto Barili, Application Engineer at RKB Bearing Industries. Today I'm going to show you the main features of the pin-type cages we use for our large-sized cylindrical and tapered roller bearings. Typically, this type of cage is used when a significant increase in bearing load capacity is required, compared to the traditional window-type cage design. As you can see from the ISO formulas, the greater load carrying capacity of the pierced roller design is mainly due to the increased number of rollers. Let's see a real case study. Same bearing, but on the left, the version with pressed steel cage and solid rollers, and on the right, the one with pin-type cage and pierced rollers. As you can see, the number of rollers increases from 38 to 39. This small change, with other internal dimensional improvements, leads to an LTEM value higher by nearly 37%. For both cylindrical and tapered pierced roller bearings, the components of the cage rollers assembly are rollers, pins, and cage rings. Let's see in more detail the design of both 4-row tapered and cylindrical roller bearings. Here is a list of the main features of our 4-row tapered roller bearings with pierced rollers and pin-type cage. All these features, such as the preset or custom BEP, allow to make assembly, disassembly and maintenance operations easier and to maximize the bearing life. In this picture, you can see all the parts of the external and internal assemblies that form a 4-row tapered roller bearing with pierced rollers. The outer assembly is usually made up of 3 outer rings, or caps, separated by 2 spacers. The inner assembly, on the other hand, is made up of 2 inner rings, also called double cones, separated by the central spacer. These are the main features of our 4-row cylindrical roller bearings with pierced rollers and pin-type cage. And here is the exploded view of the bearing. The outer assembly includes 2 side flanges and 2 outer rings, separated by the central spacer. In the inner assembly, the 2 inner rings are in direct contact with each other. Let's now have a look at how difficult it is to produce premium bearings with pierced rollers and pin-type cage. To better express the concept, let's give an overview of the most common failures in low-quality bearings of this type. Typically, the most critical areas are the welding of the cage rings, the pin-cage threaded coupling, and the entire roller pin cage assembly. Here is an example of failure related to the roller pin cage assembly. As you can see, the fracture of some rollers and the fracture and deformation of some pins during bearing rotation caused the immediate bearing seizure with an unplanned production stop. In this case, instead, you can see an example of incorrect pin cage fit and improper welding of the parts. It is clear how the non-uniformity of the welded area and the wrong position of the pin cannot lead to a proper cage assembly. In the micrograph on the left, another welding problem is shown. In addition, on the right, you can see how the result of a cage assembly measurement with a CMM machine clearly indicates that the points given by the intersection between the projection of the axis of symmetry of the pins and the axis of rotation of the bearing are not close enough. This means a serious cage assembly problem. Finally, in case of inadequate tolerances due to low-quality manufacturing, the fit between pins and cage holes is not okay and may cause premature wear between the parts, as you can see in the picture on the right. In view of all this, it is obvious that a low-quality, no-brand bearing seems a good initial investment because of the money saved, but in the mid-long term it may bring about incredible losses in terms of lack of production and therefore money due to equipment downtime and repair. And this means a sharp increase in your total cost of ownership. To avoid similar problems, it is necessary to pick a premium pierced roller bearings that optimizes the results of engineering, R&D, quality assurance and manufacturing in a continuous improvement process. RKB has put together all the latest advancements in technology to obtain state-of-the-art bearings with pin-type cage and pierced rollers. This type of product has some critical areas that should always be focused on in order to optimize the bearing performance. These areas include: Point A. The location tolerances of the cage ring holes. Point B. The radial clearance between each roller hole and the related pin. Point C. The axial clearance between the cage rings and the afferent roller spherical or flat face. Point D. The special sorting tolerances of the rollers. Here you can see how a cylindrical roller bearing with pin-type cage and pierced roller is assembled. The secret of an excellent assembly lies in the use of special spacers that must be interposed between the two cage rings in order to allow a precise and constant spacing along the circumference. Once the spacers are in place, the rollers are inserted and the pins are screwed in and their opposite ends are welded. In this case, instead, you can see how tapered roller bearing with pin-type cage and pierced rollers is assembled. The assembly on the cage rings on the cone takes place through the application of special spacers that will be removed to make room for the remaining pins and afferent pierced rollers. In this sequence, all the steps necessary to assemble a pin-type cage, from the positioning of the cage rings till the welding of the pins, are shown. Here you can see the final result that we have obtained at RKB. We performed several destructive tests on the cages of high-quality RKB rolling bearings, and the results showed that the pins are well centered in the cage ring holes and that the welding has been carried out correctly. Highly technological operations play a crucial role in cage manufacturing. In the last decade, RKB has invested heavily in this direction with the purchase of CNC machining centers and equipment expressly designed to obtain state-of-the-art products. The final quality inspection, necessary to validate the entire production and assembly process, is performed using CMM machines and specific tools that perform very precise and quick tests. In conclusion, here are the main benefits of using our pin-type cages for large-sized bearings. First of all, they provide superior load carrying capacities and performance thanks to the top-level technology they englobe, and that can be mastered only by a few premium manufacturers of rolling bearings. Secondly, they can be highly customized to our customers' needs and preferences. Finally, thanks to their extreme reliability, they help customers increase their efficiency while reducing TCO. That's all for today. Thanks for watching. If you have any questions, please contact your RKB technical or salesperson or your RKB authorized partner. Bye!